Hello students, the question is a battery supplies 0.9 ampere current through a 2 ohm resistor and 0.3 ampere current through a 7 ohm resistor when connected one by one. The internal resistance of the battery is option A 2 ohms, option B 1.2 ohms, option C 1 ohm and option D 0.5 ohms. So the problem is based on the topic current electricity, and in particular we have to analyze the particular circuits in two different situations when the current flowing are 0.9 and 0.3 ampere respectively. So first of all, in the first condition, the battery which is having a certain voltage, which is having a certain internal resistance, this is connected with a resistor. So this is the external resistor. The value of this external resistor is given as 2 ohms in the first case. So this is case 1. Case 1, the external resistance connected is 2 ohms and the current flowing here in this case is 0.9 ampere. So a current of 0.9 ampere flows in this particular circuit in first situation, in first case, and in second case the battery is same, having same voltage and same internal resistance, and it is connected with some another value resistor which is of 7 ohm. So the resistance, the resistor connected in the second case is having a value of 7 ohms, and the current flowing in the second case is 0.3 ampere. So this is the current in the second case. So this is our case number 2, and this is the current which is flowing here in the second case. We have to find out this resistance, internal resistance. So we have to find out this small r, which is the internal resistance. So what we have to do is we have to use the concept of Kirchhoff's voltage law. We have to use KVL in both the situations. So for writing the KVL equation, so this current of 0.9 ampere is flowing through this 2 ohm resistor. In passive element, the current enters at the terminal is denoted as positive, and the current leaving the passive element, in this case as a resistor, is negative. So we write down this term as positive term, 0.9 ampere multiplied by 2. So this is the first voltage term. Now we have applied the Ohm's law here to write this voltage. So current multiplied by resistance is the voltage across this 2 ohm resistance. Now this is a series kind of a circuit. Now the current flowing through this internal resistance is also same, 0.9 ampere. So the voltage drop according to Ohm's law, this is 0.9 ampere multiplied by R, small r. And now the current is entering at the negative terminal of this particular battery. So minus V, and this is become 0 because the whole loop is traversed one time. So we get this value as 1.8 plus 0.9 R equals to V after taking minus V in the right hand side. So this is our equation number 1 here. Now in the similar manner we apply the KVL in the second situation. In the second situation the current flowing is 0.3 ampere. So the first term corresponding to the voltage across this 7 ohm resistor is, this is 0.3 multiplied by 7. Then the current goes through the internal resistance though, so the voltage drop across it 0.3 multiplied by small r minus V equals to 0 because the current is entering at the minus terminal of the battery. Now taking the negative V in the right hand side and multiplying 0.3 by 7, so you get this value as 2.1 plus 0.3 R is equal to V. So this is our equation number 2. So what we do is we subtract equation 2 from equation 1. So 2.1 plus 0.3 R equals to V. This is equation number 2. Now subtracting this equation from first equation, so we get this value as minus 0.3 and plus 0.6 R is equal to 0. Or we can say that this becomes 0.6 R is equal to 0.3. Or we can say that small r is equal to 0.3 upon 0.6, which is equal to 1 upon 2, which is equal to 0.5 ohms. So the internal resistance of the battery comes out to be 0.5 ohms. This is the value of small r. So the option D is correct here. Option D is the correct choice here. 0.5 ohm is the internal resistance of the battery. So यहाँ पे एक जो प्रॉब्लम पूछी गई है करंट इलेक्ट्रिसिटी टॉपिक से पूछी गई है. एक बैटरी ली गई है जिसकी की इंटरनल रेजिस्टेंस हमें पता नहीं है, उसे हमें कैलकुलेट करना है। 4 ऑप्शंस दिए हैं, उनमें से हमें देखना है कि कौन सा ऑप्शन करेक्ट होगा इंटरनल रेजिस्टेंस के लिए। फर्स्ट सिचुएशन में 2 ओम का रेजिस्टर यानी कि एक एक्सटर्नल रेजिस्टर कनेक्ट किया गया है जिसमें कि करंट 0.9 एम्पियर फ्लो हो रही है, ये केस 1 बोला हमने। केस 2 में कहा गया कि 0.3 एम्पियर की करंट फ्लो हो रही है अगर 7 ओम का रेजिस्टर लगाया जाए। दोनों ही केसेस में हमने केवीएल की इक्वेशन लिखी। केवीएल के अकॉर्डिंगली हमें अलग अलग एलिमेंट्स के वोल्टेज लिखने पड़ते हैं और एक पूरा लूप ट्रैवर्स करना पड़ता है। तो 0.9 इंटू 2 ये पहला टर्म आ गया, 0.9 इंटू स्मॉल आर दूसरा टर्म आ गया। बैटरी के नेगेटिव टर्मिनल पे करंट एंटर कर रही है तो माइनस वी लिखा हमने, इक्वल्स टू 0, पूरा लूप ट्रैवर्स हो गया। माइनस वी को हम राइट हैंड साइड में ले गए तो हमारी पहली इक्वेशन बनी, 0.9 को 2 से मल्टीप्लाई किया 1.8 एंड 0.9 आर। इसी तरह से दूसरे लूप के लिए हमने इक्वेशन लिखी 2.1 प्लस 0.3 आर इक्वल्स टू वी। इक्वेशन 2 को इक्वेशन 1 से सब्ट्रैक्ट किया क्योंकि हमें वोल्टेज नहीं निकालना है, हमें इंटरनल रेजिस्टेंस निकालना है, तो हमें वी को एलिमिनेट करना पड़ेगा। तो हमने यहाँ पे आर की, स्मॉल आर की वैल्यू कैलकुलेट करी जो कि निकल के आती है 0.5 ओम्स। सो ऑप्शन डी यहाँ पे हमारा करेक्ट ऑप्शन होगा। सो होप यू अंडरस्टैंड द एक्सप्लेनेशन। थैंक यू।